Hello dear students. In the last lecture we have discussed about the constraint optimization. We have also discussed that there are two methods to solve a constraint optimization problem. The first method was the substitution method and the second method was known as the Lagrangian multiplier method. In the substitution method we have a constraint function. Similarly, we also have the objective function of the business firm. So, by using the substitution method, we have derived expression for x from the constraint function and then substituted that expression into the original objective function of the business firm for y. After finding the value of y, then we have substituted the value of y in the constraint function to find out the value of x. After finding the value of both x and y, we have substituted both the values in the original profit function in order to find out the total profit of the business firm. But sometimes we have the constraint function which are too complex, which we are unable to solve for one of the decision variables easily. In that case, we are using the Lagrangian multiplier method. So, I have also discussed for the Lagrangian multiplier method, we need to form a Lagrangian function. I already told you that for forming a Lagrangian function, we need to write the original objective function of the business firm plus lambda times the constraint function of the business. So, now I am going to show you that how we will write the Lagrangian function and how we will solve that function in terms of the unknown variables. So, this is the original function we have, let me call it equation 1, and this is the constraint equation which is known as equation 2. So, profit depends on x and y units and x plus y must not exceed 12 units. So, this is the constraint function the business firm is facing and this is the original objective function of the business firm. Now, Lagrangian function. How we will form the Lagrangian function? So, I have told you that Lagrangian function is equal to objective function plus lambda times constraint function, and we will set Lagrangian function equals to 0. Let me do it. Objective function. This is the original objective function of the business firm. Constraint function, this is the constraint function. So, I will use the symbol L pi. Pi stands for the profit function and L means Lagrangian. So, L pi means Lagrangian function. This is equal to ATX minus 2x square minus xy minus 3y square plus 100y. This is the original objective function plus lambda times constraint function. This is the constraint function. Let me write it simply. X plus y minus 12 is equal to 0. This will be my second equation. Suppose this is the original equation, original objective function, and this is the constraint function. X plus y minus 12 is equal to 0. So, This was the original objective function plus lambda times x plus y minus 12 and set it equal to 0. This is known as the Lagrangian function. This whole function is known as the Lagrangian function. The Lagrangian function can be treated as an unconstrained function in three unknowns. And this unconstrained Lagrangian function, we have three variables or three unknowns. What are they? The three unknowns are x, y and lambda. X, y and lambda. These are the three unknown variables in this Lagrangian unconstrained function. So, we will solve the Lagrangian function for x, y and lambda. We need to find out the value of x, y and lambda from the Lagrangian function. So, to maximize Lagrangian function, to maximize this function, we will write partial derivative. We will take partial derivative with respect to x, then with respect to y, and finally with respect to lambda. And we will set each of the expression equals to 0 to find out the value of these three unknown variables. For example, taking the partial derivative with respect to x, we will take partial derivative L phi with respect to x. Then we will take partial derivative of this Lagrangian function with respect to y. So, we will write L phi with respect to y. We will write the expression here. Then finally, we will write the Lagrangian function with respect to lambda. And we will set each of the equations equal to 0 to find out the value of x, y and lambda. Now first, we are going to take the partial derivative of this Lagrangian function with respect to x. We can write it at minus 4x minus y, at minus 4x minus y plus lambda. For example, if we multiply, or we can write it after simplifying this expression, like we can also write it lambda x plus lambda y minus 12 lambda. So, if we take derivative, if we take the partial derivative of this Lagrangian function with respect to x, we can write only lambda here, because this will be cancelled out as we have no x here. Similarly, this will also be cancelled out as we have no x here, and from this expression we can write only lambda by applying the rules of derivative. So, this will be the expression for x. This was the original Lagrangian function. So, we have taken the derivative, the partial derivative of this Lagrangian function with respect to x, and we derived this expression, keeping it equal to 0. Let me call it equation 1. Now, we are taking the partial derivative of this Lagrangian multiplier function, this Lagrangian function with respect to y. For y equal, this will be cancelled out, only minus x minus 6y plus y, and same is the case here, lambda y will be cancelled out with y, so plus lambda equal to 0. Suppose this is equation 2, minus x minus 6y plus 100 plus lambda equals to 0. This was the partial derivative of the Lagrangian multiplier function with respect to y. Now, we are taking the partial derivative of this Lagrangian multiplier function with respect to lambda. All these terms will be cancelled out as we have no lambda in this expression. So, from this case we can write it lambda x plus lambda y minus 12 lambda. So, we will write x y minus 12. So, it means that x plus y minus 12. This is the partial derivative of the Lagrangian function with respect to lambda. We will set equal to 0. Let me call it equation 3. Now we have 3 equations. We need to solve these equations simultaneously in order to find out the value of x, y and lambda. So, how we will solve these equations? This is equation 1. This is equation 1, this is equation 2 and this is equation 3. So, solving equation 1, 2 and 3 simultaneously, we can get the value of x, y and lambda. It means that x is unknown, y is unknown and lambda is unknown. We need to find out the value of these 3 unknowns from these 3 equations. How we will solve these equations? So, we will subtract equation 2 from 1. We can write it as equation 2 from 1. This is equation 1. So, at minus 4x minus y plus lambda equal to 0. This is equation 1 and equation 2. Let me arrange it. This is the equation 2. I am going to arrange this equation to make the process simple. So, 100 minus x minus 6y plus lambda equal to 0. This is the equation 2. We are going to subtract equation 2 from equation 1. So, we can write it as minus 20 if we subtract this. So, minus 20 minus 3x plus 5y equal to 0. For example, this is equation 4. Minus 20, this is minus, so we will change the symbol, plus minus to plus minus to plus plus minus. So, we will cancel out this plus lambda with minus lambda plus 6y minus y plus 5y, and this is this is plus, this is minus, this will be cancelled out, minus y plus 6y. So, means plus 5y plus x minus 4x minus 3x minus 100 plus 80 minus 20. So, this is equation 4. Now, multiplying equation 3 by 3, equation 3 by 3, multiplying equation 3 by 3 and then adding it to equation 4 and then adding it the resulting equation to equation 4. So, this is the equation 3. First we will multiply equation 3 with 3. So, x plus y minus 12 is equal to 0. This is equation 3. Multiply it with 3. 3 into x plus y minus 12 equal to 0. Multiply 3. This will become 3x plus 3y minus 36 equal to 0. Suppose this is equation 5. We have multiplied equation 3 with 3. This is the resulting new equation which we denoted with 5. So, this is the equation 5. Now, we are going to add this equation with equation 4. So, let me write it. This is the equation 4 and we are going to add both the equation. This is equation 4, this is equation 5. We are adding both the equations to each other. So, minus 36, I am just rearranging this equation, plus 3x plus 3y equal to 0. I am adding both the equations. This is equation 5. I am adding both the equations. So, minus 20, if we add, we can write it, this will be cancelled out, we can write it 8y equal to 0 and we add this one minus 56. Minus 20 plus minus 36, we can get minus 56 plus 5y plus 3y, we can get 8y, minus 3x plus 3x cancel out. So, from here we can find out the value of y, solving this expression for y. So, 8y is equal to 56. This implies that 8y divided by 8, dividing both sides of the equation by 8, 56 divided by 8, cancel out 7. This implies that y is equal to 7. This is the value of y. So, we have derived the value of the first unknown. Now, for the value of x, the expression was x plus y minus 12 is equal to 0. This was the expression. Substituting the value of y into this expression. So x plus y 7 minus 12 is equal to 0. This implies that x 7 minus 12 minus 5 is equal to 0. This implies that x is equal to 5. Now this is the value of x. We derived the value of y as 7 and the value of x as 5. So for lambda we will substitute. Now finally we have only a single unknown, which is lambda. So for lambda substituting the values of x and y into equation 2. This was the equation 2. The equation 2 is minus x. The equation 2 is minus x minus 6y plus 100 plus lambda equal to 0. This was the equation 2. So for the lambda we are substituting x5, substituting x is equal to 5 and y is equal to 7 in equation 2. Let me substitute x5. This implies that minus x5 minus 6y 7 plus 100 plus lambda is equal to 0. This implies that minus 5 minus 42 plus 100 plus lambda is equal to 0. After solving this equation we can write it, or we can write it, for example, minus 5 minus 42 minus 100 is equal to minus lambda. When we solve this expression we can get minus 5 minus 42 and minus 100 for lambda. So we can write the value of lambda is minus 53. So x was 5, y is 7 and lambda is equal to minus 53. These were three unknown in the Lagrangian function. Now they are known, but this lambda is having some significance in the managerial economics in terms of analysis. What do we mean by lambda? What does it show? So lambda, it is the marginal effect on the objective function solution associated with a unit change in the constraint. It is the marginal effect on the objective function solution on the objective function on the objective function solution associated with a unit change associated with a unit change in the constraint. This is the definition of lambda. What is lambda? Lambda is showing the marginal effect on the objective function solution associated with a unit change in the constraint x plus y is equal to 12. This is the constraint function we have. So it means that if we increase or decrease these units, for example, if we make it 13 or we reduce the constraint function by 1 unit 11, so the profit will change by the value of lambda. It means that a decrease in the output capacity, this was the output capacity, if we decrease it, for example the original was 12, if we decrease the production capacity of the business firm to 11, mean 1 unit, if we decrease the output capacity from 12 to 11 by 1 unit, or if we increase the production capacity of the business firm from 12 to 13, in this case 1 unit decrease and in this case 1 unit increase. So the total profit of the business firm will change by about $53. It means that changing the output capacity from 12 to 11 means 1 unit decrease. It means that according to the value of lambda, if we decrease the value of output capacity from 12 to 11, if we decrease the output by a single unit, so profit will change by $53 with a negative sign, decrease. If we increase the output capacity from 12 to 13, the total profit of the business firm will increase by $53 with a positive sign. So it means that decreasing a single unit of the output capacity from 12 to 11, the total output of the business firm will reduce by minus $53. And if we increase the output capacity of the business firm from 12 to 13, it means that the total profit of the business firm will increase by $53. So this was the interpretation of the third unknown variable, which is called lambda. So this was the constraint optimization topic. In this topic we have discussed about the unconstrained optimization, about the constraint optimization, because we know that every time the business firm is not free to take action regarding the decision of output. So every time the business firm faces some legal constraints, some environmental constraints, some physical constraint, some financial constraints, so he must restrict his decision in terms of constraints. He is not free to take actions regarding the amount of output. it doesn't mean that, for example, if he wants to produce 13 units, but his restrictions, the constraint function restrict him to produce his output up to 12 units. So for the constraint optimization problem, we have discussed two methods. The first method was the substitution method, and the second method was the Lagrangian multiplier method. So in both the methods, we have discussed that how we can solve the constraint optimization problem with the help of substitution method as well as the Lagrangian multiplier method, and then we have also interpreted the value of lambda. So this was the optimization technique. This was the last topic of the optimization techniques chapter. So it means that, for example, sometimes we are freely take decisions in terms of output units, but sometimes we are restricted ourselves to the units that are restricted, mean that are assigned to the business firm to restrict his decision up to that units. So this was all about the optimization techniques, that how the tools of mathematical economics can help in order to solve managerial decision problems. Thank you so much for today. See you in the next lecture. Goodbye.